Hi guys, so in this lesson what we're going to look at is probability, and we just have a quick introduction to what probability is, and we're going to look at experimental probability for this exercise. So you can have a quick read of this yourself. Probability is the mathematical treatment of the idea of chance. There's a load of examples there. For example, getting a head when a fair coin is tossed 4 times. What's the probability of that happening with all heads when a fair coin is tossed 4 times? Getting a total of 10. We're choosing numbers from random, etc. So let's just go through a couple of definitions and then we'll look at an example at the end. So the first thing we need to know what an experiment is. We've already talked about the idea of an experiment. So pick a card, choose 2 numbers, roll a die. Now what we need to be able to is identify an experiment and realise it's independent. And independent means that one does not affect the other. And what that means is if I roll the die and I get a 6, I have exactly the same probability of getting a 6 the next time I roll the die. Now if we carry out the experiment once, it's called a trial. The outcomes or the sample points. Now each possible outcome is referred to as a sample point. So for example, if I roll a die, the possible outcomes or the sample points are the numbers 1, 2, 3, 4, 5 and 6. And that means that sometimes we're able to easily count them, sometimes we're not. The sample space is the set of all possible outcomes. We call that the outcome space as well. And for example, if we were just choosing a number from random, from the whole number between 1 and 10, you can see the sample space here is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. It's a bit like set theory, lads. An event is something that may or may not happen. So for example, if I'm looking at drawing a card from a deck of cards, then an event is what we want to happen is you getting a diamond, and obviously for number of diamonds in a pack of cards is 13, so there'll be 13 possible outcomes for this to happen. Experimental probability, that's usually what happens in the real world. We don't often know what the probability is going to be, so what we do is we set up an experiment, run a number of trials, and then this provides an estimate of the true probability. So for example, here, suppose we toss a coin 100 times and get 46 heads and tails 54 times, then we can say the probability of the number of heads occurs is equal to 46 over the number of trials, which is 100, which is equal to 23 over 50. Now that's roughly half, which is what we'd expect on a theoretical level if the coin was fair. And we also have statistical analysis to check to see whether or not this is true, or this is a true, or whether or not, the coin is biased or not. Okay, theoretical probability is the sort of thing that we've been dealing with here. So as we just said there, we expect the probability of an event of getting a head would be a half, and eventually that's what's going to happen. It's called the theoretical probability. So if we kept doing that experiment instead of being 23 over 23 over whatever it was on the other slide there, what you'll find is that as n increases, okay, you'd expect it to go towards a half. And expected numbers of repeated trials, so suppose we've already worked out the probability of an event happening, and if there are n trials of that, then it's just going to be n by p. So again, for example here, probably getting a head when a coin toss is a half, thus the expected number of heads when a coin is tossed 1,000 times is n by p, and you see n is 1,000 here, p is a half, and n times p is 500. And of course you'd expect that out of 1,000 tosses of a coin, you'd expect around 500 of them to be heads and 500 to be tails. Okay, let's have a look at this example. So it says here, a small restaurant records the main choices of its customers over a period of time. We've got the results here, so we've got 22 people had beef, 54 chicken, 76 had fish, 10 were vegetarian, and 38 had the lamb dish. So how many main courses were recorded? Well, that shouldn't be too difficult. I think even you can do this, guys. It's 22 plus 54 plus 76 plus 10 plus 38. If you add all those up, it comes out to be 200. Okay, nice and straightforward. So that's the total number of dishes. So what's the probability the new customer will choose lamb as her main course? And is this experimental probability or theoretical? Well, based on the figures that we've been given, we know that lamb was chosen 38 out of 200 times. And if we work that out, you can see we can divide both sides by 2, get 19 over 100, which is equal to 0.19 or 19%. So there's all the ways you can actually write that. Guys, I prefer to either use a decimal or a fraction. It's much easier to work with decimals and fractions than it is with percentages. Now the next question with that was, is it experimental or theoretical? Well, it's experimental because we've obviously done a load of trials here. We're just checking to see what people are eating. So for this one, it's experimental probability. The last thing it says, okay, is that the restaurant has bookings for 40 people one evening. How many lamb courses can expect to serve that evening, rounding up to the nearest whole number? Well, we're expecting from part 2 here, we're expecting 19% or 0.19 of them to be going to go for the lamb dish. So remember what we said, it was N by P. So NP is equal to the number, which is 40, times the probability, which is 0.19. And then all you do is you get your calculator out. And if you do that, it comes out to be 7.6. And of course, then we need to round it up because that's what it asks us to do. So 8 people expected out of 40 to go for the lamb dish. If you have a look at the exercise, guys, on it's exercise 22.1, it's on page 18. Okay, if you have a look at that, then what you'll see is that it's pretty much set up as this type of question, and all you have to do is work through and make sure you're able to work out the experimental probabilities that they're asking you for. All right, hope all of you understood what was going on there. If you didn't, then drop me a quick email or leave a message on the Google Classroom.